Welcome to third part of NumPy in Python. In this video, first we can go through iterating over an array. What do you mean by iterating? Iterating means going through elements one by one, visiting each elements of an array one by one. We can do this using basic for loop of Python. And if we iterate on a one-dimensional array, it will go through each element one by one. We'll see how iteration can be performed with an example. For that, import NumPy package, create an n-dimensional array. In the first case, we are creating a one-dimensional array. For x in ARR, this for loop will help to traverse through this array. So in each iteration, x is assigned a value of this array. So in the first iteration, x is assigned value 1. Print x will print 1. And second iteration, x is assigned the value second element of the array, which is 2. The third iteration, it is assigned the value third element of the array. And this procedure will go on till the last element of the array. Again, see the next array declaration where we are declaring a two-dimensional array. So if we use the same loop as given before, what happens? Here for x in ARR will help to traverse this array, which will traverse the first element of the array. The first element of array is again a one-dimensional. So this entirely it's a two-dimensional array. The first element is again a one-dimensional array. So for x in ARR means x is assigned a value this array 1, 2, 3. So print statement will print the array with elements 1, 2, 3. The next iteration, x is assigned the value second array, which is the array with elements 4, 5, 6. What we need to do, if we need to traverse again element by element of this inner arrays, for that we need to use two for loops or an inner for loop, or we need to do nesting of loops. So the same example I am doing, again we are creating an n-dimensional array. It's a two-dimensional array. For x in ARR, this will help to traverse in each iteration. It will be assigned, in the first iteration x will be assigned the value this array. In the second iteration x will be assigned the value second array. The inner for loop will help to traverse through each elements of x. That means each element of the innermost array can be traversed with the help of second for loop. So in that case, the element by element can be traversed and displayed. Next is an example where we are creating a three-dimensional array and iterating. So here for x in ARR, in this case, this will be assigned to x and the print statement will print that whole array, which is a two-dimensional array. And in the next iteration, x is assigned value of this array and the print statement will print it. So this is how iteration happens in Python with the help of NumPy package. We can either traverse element by element in case of multi-dimensional array, or we can traverse through a array. Inner arrays can be traversed as a whole. Special function NTITER, n-dimensional iteration. This is a powerful function in NumPy package that helps to iterate through elements of an array. And it is basically used to iterate through multi-dimensional array very easily. So the function NTITER is a helping function that can be used from very basic to very advanced iterations. It is an efficient function to traverse multi-dimensional array, or it's an efficient multi-dimensional iterator object using which it is possible to iterate over an array. Each element of an array is visited using Python standard iterator interface. If you see the example and output, it will be very clear of how this NTITER function works. Import NumPy package, create an n-dimensional array, If we use a single for loop, will be help to traverse through entire array as shown in previous example. But see how this NTITER function works. This will help to iterate through each and every elements of inner arrays. So see the output. Next, iterating with different step size. And this NTTIR function not only helps to iterate through elements one by one, we can skip few elements in between. See the example. If the step size is specified, here the step size is specified as 2, which means that alternate elements are skipped while iterating. So the result is 1, 3, 5 and 7. So by using a step size value in the NTITR function, it helps to iterate through an n-dimensional array by skipping few elements. If it is 2, it will skip one element in between. We'll see ndenumerate function, n-dimensional enumerate function. Enumeration means mentioning sequence number of something one by one. If I need to specify the index number of elements in an array, in that case I can use ndenumerate function. Sometimes we require corresponding index of element while iterating. For that, ndenumerate method can be used. In such cases, if we need to print both the element and its index number, in such cases ndenumerate function can be used. We will see the usage with the help of an example. Here again, we are declaring NumPy package, creating an n-dimensional array, and see for with the help of two variables idx, x and np.ntenumerate arr of this function of this array arr, we are calling ntenumerate function with two variables. So idx and x, and what will be assigned to each value idx and x? See the print. To the variable idx, the index number will be assigned, and to the variable x, the value in that index or the corresponding numeral or number in that index location will be assigned, or the value of element in that index location will be assigned. So print idx, x will print two values, the index location together with the value. Same thing happens when we do with a two-dimensional array. This ntenumerate also will help to iterate through element by element in case of multi-dimensional arrays. So while seeing the example, you can be clear. The first three values are of one-dimensional array, where these are the values of the two-dimensional array, where index locations are printed initially, then followed by the value. So that's the purpose of ndenumerate, n-dimensional enumerate function. Next is how we can manipulate array using NumPy package. Many functions are there. Few of the functions we have already covered, but we will go through few important functions for array manipulation. For changing the shape of an array, few functions in the NumPy packages are given here. They are reshape, flat, flatten and ravel. Reshape gives a new shape to an array without changing its data. Flat, it's a 1D iterator over the array. Flatten returns a copy of the array collapsed into one dimension. A multi-dimensional array can be converted to a one-dimensional array using the flatten method. Ravel returns contiguous flattened array. So these are the few methods that helps to change the shape of an array with the help of NumPy package. Now we'll see the reshape function. The reshape function has three parameters: arr, the array to be reshaped. Then the second parameter is new shape, which is either an int or tuple of int. And we should be sure that the new shape is compatible with the original shape. And order for column major or row major. See the usage of reshape function with an example. For that, again import NumPy package. Create an n-dimensional array in p.arange of 8. We'll create an array with elements 0 to 7. So while printing the original array, we get the answer like this. The elements of array are from 0 to 7, but the last element 8 is omitted. And B is equal to A dot reshape 4, 2. This will reshape the array A with 4 rows and 2 columns. And see the result of modified array, which is a multi-dimensional array with 4 rows and 2 columns. So one-dimensional array is reshaped to a matrix of dimension 4 by 2. This is the purpose of reshape function. Now we will see the flatten function. The flatten function is to convert a multi-dimensional array to one-dimensional array. See the example here. Here we have declared, or we are creating an n-dimensional array, one-dimensional array in the range 0 to 7, and we are reshaping to a multi-dimensional array 2 by 4 matrix. So the original array is like this, and we are calling the flatten function. In the second case, we are calling the flatten function with order equal to f. In the first case, while flattening, it will consider first row elements initially, followed by the second row elements. But in the second case, see how the flattening is done. 0, 4, 1, 5, 2, 6, 3, 7. Column wise it is flattened. So that's the difference between, or that is the difference where what happens when we use this order parameter. The next is Ravel function. This function returns a flattened one-dimensional array. A copy is made only if needed. The returned array will have same type as that of input array. And the syntax is numpy.ravel. The first parameter is A and the second parameter is order. Order is again C or F, row major or column major. See the example. Here also it will do the same as a flatten function. The result is same. We will see few other array operations. Initially, we will see how we can perform transpose operation. For that, NumPy supports a package called transpose, numpy.transpose. And the parameters are ARR and access. ARR, the array to be transposed. Access, list of ints corresponding to the dimensions. By default, the dimensions are reversed. That is, if it is a 2 by 4 matrix, the dimension will be, access value will be 4 by 2. Example, import NumPy package, create an array and reshape it to 3 by 4 matrix. See the output of the original array. It's a matrix with 3 rows and 4 columns. Now we are displaying the same array after performing the transpose function. NumPy package.transpose, which array to be transposed is the first parameter. So this was a 3 by 4 matrix. By default, it will be transposed to 4 by 3 matrix, 4 rows and 3 columns. See the result. So these operations are performed in traditional languages using a lengthy code. All these can be performed very easily by using a function call in Python. And that's the power of Python, and that's the power of NumPy package. There is another mechanism to perform array transpose, numpy.ndenumerate. It behaves very similar to NumPy transpose. See the program and output. Instead of using transpose, that is numpy.transpose of array value, what we are doing? If A is the array, A.t will perform the transpose operation. Very much similar to the transpose, but we can use this A.t very easily than the transpose function. In this video, we have covered how to iterate over an array and iterate over multi-dimensional array. For that, there are some powerful functions in NumPy package and few array manipulation functions like reshaping, transpose, etc. Thank you for now.